Hi, this is Spencer Holloway, and I'll be speaking on behalf of my other group mates, Zack Lowdermilk, Tommy Lee, and Lucas Juttner, and this is our submission for the final project. As you can see here at the top, I import the needed libraries. We also use the Adafruit char LCD, the Adafruit DHT, and we import FTP because that's what we use to access the CMIS site. Here you see some code for linking the LCD with the little I2C connection behind it. All of this code was pulled from the Freenove site. Okay, and our code breaks down into 7 main functions. First is the setup function here that just sets the pin numbers for the motion sensor and the relay pin and sets warnings to false. Here's our CSV to dictionary, and then here we read details from the CMIS CSV and store all info pertaining to the current date that's populated with data. If the values for a certain time or hour haven't been updated yet or they don't exist, we just display the times that fail, and then at the end we return that dictionary. You can see here it failed on this hour. It just finds the row in the CSV and kicks that back out. Next one here is compute ETO, and then all this does is that for each local humidity and local temp average, we use that with the hourly CSV data, CMIS data, and use the provided equation to derate, like as shown in the Canvas PDFs. Here, the compute gallons, it calls the CSV to dictionary function to populate the dictionary values, and then it computes the gallons per hour based off the set of values within that dictionary, and also based on the missed hours. Afterwards, you can see, where is it, right here, we call the compute ETO function for each hour and the missed hours, and get the average gallons to water for all those hours that are in that buffer. Yep. Using this equation here at the end to kick that back. Okay, these two, the retrieve data and process data, mainly with those two is that it opens the FTP instance, accessing that CMIS site, logging in, using the location ID of 75 for Irvine, and then populating the CSV with just the values here with our CSV reader, using the CSV.dictionary reader, and it returns it. Let's see. After that, this is right here, is the relay motion. This is the function that we call after we've calculated the averages and got the time to water. Here what it'll do is it'll set the message to watering, the times passed in, and checks the time and makes sure it's less than that timer, and it just keeps it going as the timer decreases. As you can see, it's also connected to the motion pin here, and if it detects motion, it's gonna turn off the relay, display a message saying that motion is detected, and what it does is it keeps the time that motion was detected and adds it back to this timer here so that we ensure the correct amount of time to water. Other than that, it turns the relay back on, cleans up, and clears the LCD when it's done, as this is a thread that's called. Here's our test function. This is the main thread. Some of our variables. Here's where we use a DHT sensor to get readings from the DHT humidity and temperature every 60 seconds, and it adds it to a running total with a running counter, and then averages it at the end of the hour. And then if our time is greater than the timeout, which is an hour, it averages them, displays those averages onto the LCD, and then calls our CSV and all of the functions that get us our averages from the CMIS site. If gallons hour returns 0, meaning that it's either 0 or the site hasn't updated, it'll just do stalling, add another hour, so then it can just pull the next hour's worth of local data. If not, it'll calculate using the provided equations, give us a time to water, and then call the thread for the relay motion, and sets, just like this one above, sets the totals, counters, and the timeout, and just restarts the process. And it does that as long as we have it on. And this is just our little main that kicks off the main thread that hops to what we just showed here for test. Some keyboard interrupts to clean up the pins, clear the LCD, and right here calling setup in main. And that's it. Thank you. Okay, now we'll be demonstrating taking DHT readings. As you can see here, RD2 have been calculated or read in, and there's a running total, running humidity totals, and there comes another one. And as you can see here, the temperature went up a little bit, and that's because these first two readings were run without the PS4 being on, and after 2 minutes of the PS4 being on, it affected our temperature reading by 1.8 degrees. So here I'm going to be testing accessing the CMIS site on an hour that didn't have any data updated yet. Here you can see I just did one little value, one reading. I'll wait 60 seconds and then access the CMIS site. Give it just a moment. Should kick out the average for that period, which of course will only be this temp total. Okay. Alright, so there you can see that the CMIS site is live, and it failed on all of these hours here. Okay, and all it does is going to add these values to the dictionary of all the past hours with values in them. Total committed ETO average is 0 because there was nothing for hour 1600 since it's 4:30. It's going to add that to that buffer, and it's going to buffer these values here. And it's going to stall and then restart the process. Alright, you can see here that 1700 was missed, so that's going to be added to the buffer, and the local averages for that hour are going to be added to the sensor buffer, and we can try again in the next hour. Alright, so what we just saw here is that after the hour, the CMIS data was activated and saw that from before, the missed hours was 1700. So when it pulled data again, CMIS had updated and the values for 1700 were there. So what you just saw was the computation for 1700, and then you can see that it missed on 1800, and did the same thing as before, is keeping the local averages onto the buffer and restarting the process.